In this question, the graph of f such that the domain -5 to 1 inclusive is mapped onto R, where f of x is equal to x cubed plus 6x squared plus 9x is as shown. So this is the graph here. And in part A, on the same set of axes, sketch the graph of y is equal to the absolute value of f of x. So what you need to do with this graph is reflect the bits that are below the x-axis, the bits that have negative y values. In other words, from here to here, those two parts of the graph, reflect them in the line y equals x, and they'll be up here something like that. And then those two bits plus this bit here will be the graph of the absolute value of f of x. When you take the absolute value of positive y values, you end up with those same positive y values. So this part will not change. Only these two parts below the x-axis will. So key things to keep in mind are that the domain is from -5 to 1. So the left-hand most x value, which is this point here, has a value of -5 and some particular y value. And this point here is the far right or extreme right value of the graph, which is equal to 1 according to this domain. So that has the coordinates 1 and something. And when you reflect this point in the line y equals x, the x value won't change, but the y value will. So that means that the reflected point will be directly above this one here, and the vertical distance it will be from the x-axis will be the same as the vertical distance this point is from or below the x-axis. So that's a key thing you must make sure you do in this kind of question in an exam. It's good to practice it when you're not in the exam so you know exactly what to do when you get a question like this. So ideally have a ruler and make sure you set it up so the reflected point is directly above it and the same distance above the x-axis as this one is below. So I'm going to do that now. Make these as smooth as you can and as close to the same shape as the bits below. And so that's the reflected part. Now filling in the endpoints. So this one here, as I mentioned before, the x value -5, and you need to find this y value here so you can figure out what this one up here is going to be. So to find the y coordinate when x is -5, sub -5 into the original equation. And so this is going to be f of -5 and replacing the x's with -5, so you get -5 cubed plus 6 bracket -5 squared plus 9 times -5, and -5 cubed is -125 plus -5 squared is +25, so that's 6 times 25. And then 9 fives are 45, so -45. Then -125 minus 45 is -170. This equals 150, so plus 150, and then that equals -20. So therefore that point is -5, -20. Therefore, so marking that in here, they don't actually ask you to do that, but you need to figure it out. The absolute value of -20 is +20. So that means that just looking at the graph, you can see that this point is higher than that point. Just to be sure, I'm going to go f of 1 and figure out the y value for here. And f of 1, subbing 1 into the functions, you get this is going to be 1, this is going to be 6, and this is going to be 9. So 1 plus 6 plus 9 equals 16. So that point would be 1, 16. All right, so this one is definitely the highest point. So it has the highest y value on the graph, and the lowest y value on the graph, as you can see, is going to be 0. So that is going to be the domain, the range. So the range from the lowest y value, which is 0, and that's inclusive. This point here went through 0, 0, and when you reflect the point 0, 0, you get 0, 0 anyway. And so 0 is part of this new graph, and the highest value, as I mentioned, is going to be 20, and that's included because this is a colored in dot, which means the point is included. So that means this y value is included. So when you reflect it up here, this whole point is also included, and it's got a colored in circle. It doesn't really look like it has, but I'll draw one to make it look a bit like a colored circle. There you go. And to label the absolute value of x, I would kind of do it like this. I would go absolute value of f of x, and then point to this part, and I'd also point to that part as well. So, because it's a little bit hard to draw over the top of that and make it stand out. So that's pretty much the graph drawn, and also the state the function, the range of the function, which is this one here.